everyone, I hope you're having an excellent morning. I have had a lot of coffee today and I'm definitely ready to do a programming problem. I've been kind of busy this week, so I'm hoping to get one video out this week, one video out next week, and then pick up in the time between the holidays and the new year. Post a lot of videos. So if you have anything that you specifically want me to work through, go ahead and leave it in the comment below. If you're liking this content, go ahead and subscribe to my channel. I'll try to post content at least once a week. But let's get started on today's problem. So I'm back at the 75 blind list of problems, which are just 75 questions that if you know all of these questions, you're likely to ace a FANG interview. So today we're going to talk about a question involving linked lists. So we'll talk about specifically this question called merge two sorted lists. So let's start, as always, by just reading the question. So you are given the head of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So we know we have this data structure called list node, and each node in this data structure has a value and a next pointer. So let's take this first example 1 here where we have this first node that contains the value 1, and the pointer to the next node is this pointer to 2. This contains the value 2 and points to the node that contains the value 4. Then we reach the end of the list. So the next pointer is none. That's the default next pointer. So in this example, let's look at how we can merge the two lists. Now, I don't really particularly like this example because the first two nodes are 1. So I don't think it's a really good example to start because how do you know which list you're picking elements from? In this case, they chose to pick the elements from the purple list. We'll just say that this linked list here is like the answer list. So they chose to put 1 here, then 1 here, then looking between 2 and 3. Okay, 2 is smaller than 3, so 2 here, 3 here, so on and so forth. So let's go through maybe perhaps an easier example where we look at some lists. So here's the answer that I had previously, but I'm going to go ahead and delete that while we just talk through this answer. So we have some pointer that's initialized to the head of each list. So let's say these pointers are initialized to 1 and 2. So this list 1 has 2 nodes, this list 2 has 3 nodes, and we want to merge them to make one list. So where do we start? Well, we need to look at the value inside the list to determine which one goes in our answer list. So let's say we have some answer list, and that's this list here. Now the pointer is pointing to 1 and 2. Well, which is smaller between 1 and 2? 1. So we will add node 1 to the head of our list. So let's give ourselves some pointer here where, okay, 1 points to the head of our list. Now we advance this pointer to look at the next number. It's just as easy as that. Now between 2 and 5, which one is smaller? 2. So we will go ahead and add 2 to our answer list. And now what we need to do down here is we need to make sure that there's a pointer from the previous node to the current node. So there we go. We add a pointer. Now our answer list points from 1 to 2. Now we advance this pointer. So on and so forth until we reach the end of the list. Now we're at the end of the first list, so there's nowhere else to go. This pointer arrow points to nothing, it points to none. So we need to say, okay, now there's still values left in list 2, so we need to just use all these values left in list 2 and add them here to our resulting linked list. So this is kind of the algorithm that we're going to follow to result in this answer. Then we'll return the answer. So let's go back to our problem statement. Let's sketch out the algorithm how we want it to behave. So we need to first consider the base cases. If either list is empty, you return the other list. So first, or let's just say algorithm, check for empty lists. And by empty lists, I mean singly linked lists. These aren't like the list data structures that are inherent in Python. Again, this is a special kind of list called a linked list where we have values and pointers to the next element of the linked list. So after we check for empty lists, we need to start building our return list. We're going to merge the two sorted lists into one list. Then the last step is going to be to see that we're actually at the end. Check the list to see we are actually at the end. If not, append ending of list. We'll just say that. Okay, so first, if list 1 equals none, then we return list 2. Oops, you always need a colon at the end of that line. return list 2.
Now again, if list 2 equals none, return list 1.
Now we need to actually merge the sorted list into one list. So how I'm going to do this is I'm going to introduce a new linked list, and we'll call that answer. So answer equals list node. Basically creating a new list node. I'm initializing it. This first element is going to have a value of 0, and it's going to have no next pointer. So you can literally think of this as just a node that contains 0. The answer node points to the head of the list because that's what you're returning, the head of the merged linked list. I need a way to keep track of the appending values, so I'm going to have a new pointer called current, and I'm going to initialize that as answer. So the current pointer is going to start at the answer pointer, and it's going to progress through the list as we append a new value, as we add a new value to the linked list, until it reaches the end. So now our actual algorithm. I'm going to choose to do a while loop, but there are many other ways to do this, but I'm going to say while list 1 does not equal none, and list 2 does not equal none. So while both lists are not empty, let's just look at this 2 and 3. So let's say, okay, this is the list 1 and this is list 2. So if the list 1 val, and how we get the value is just dot val, you're right. If list 1 dot val is less than list 2 dot val, we're going to want to merge the list 1 value into the list. So how are we going to do that? Let's just make a temp node, and let's say the temp equals list node, and we're going to pass it the value. So we're going to say list1.val. Now we need to say that the current pointer, current.next, equals temp, because we want the next pointer to be equal to that value. Then we'll say we need to advance the list 1 pointer. So list 1 equals list1.next. And that really should be it. Now we need to do the else case, so we can basically just copy this code for the else case. Once we have chosen a case, either the first case or the second case, we need to advance the current pointer. So current equals current.next. So we're done with the while loop. We merge the two lists. And in this example, they're the same length. But in the other example that I showed you, they were different lengths. So now we need the case where maybe list 1 or list 2 is longer. So if list 1 does not equal none, if we haven't reached the end of list 1, current.next is going to equal list 1. So all the rest of the values of that current list should be equal to the rest of the remaining values of list 1. Else if list 2 does not equal none, then the rest of the values current.next should equal list 2. You just return answer. There's going to be a problem here, and I want you to guess, just in your mind, think about what the problem's going to be. If you think about the way that we initialize the list nodes, maybe that will give you a hint as to what the problem's going to be. The memory limit is succeeded. Oops, right here was our error. List 2 equals list2.next. Just a small syntax error can mess up your whole program. So let's run these results. Okay, perfect. So we got an answer, but as I thought, the issue is with the 0. Because of the way that we initialize this linked node, we initialize the answer, the value of the first element is 0. So instead of just having us point to the answer, we need to point to the answer.next. Because we don't want to consider that 0 node. So let's see what we got here. So we did get the correct answer. Let's submit and make sure we pass all the Leetcode answers. And we did.
Boom, bam, bop, bada bop, boom, pow.
So we have terrible runtime, not the best memory, so there are better solutions for this. I think maybe these base cases here lend themselves very well to recursion. So there is a recursive way to do this problem. If you're interested in seeing that, comment below and I'd be happy to walk you through that solution. But I think that logically thinking through how we're going to merge different elements into this list is interesting, and then at the same time thinking about how we advance the pointers to consider the elements that we want to consider. So thank you so much for tuning in today. Again, if you have any videos that you want to see me do or any questions that you have, go ahead and leave a comment below. Have a good day, everyone.